So pedigree, in terms of genetics, it is a diagram of family relationships that use symbols to represent people and lines to represent genetic relationships. So these diagrams make it easier to visualize relationships within families, particularly large extended families. So this is looking at one individual trait. So eye color, hair color, tall versus short, rolling tongue versus not being able to roll your tongue. It's only looking at one trait. For each trait, you have to do a different pedigree. So you're going to see what that looks like in just 1 second. All right, in a pedigree, squares represent males, circles represent females. That should be easy to remember because boys are squares.
I don't get it.
No.
I don't get it either.
Ask your parents.
Because they're...
So horizontal lines connecting a male and a female represent mating. That means a sharing of genetic materials that produce a child. Vertical lines extending downward from a couple represent their children. For our class, we will shade in the shape of the person that shows the trait or has the dominant gene, and leave it empty if they show the recessive gene. So, for example, in our notes on basic genetics, we looked at orange fish and purple fish. Purple was the dominant trait, orange was the recessive trait. So if we had a purple fish, we would shade it in. If we had an orange fish, we would leave it empty. All right, so here's an example of a 3-generational pedigree. We'll say the trait we're looking at is fish color again. So capital H represents purple fish, the purple fish gene, and lowercase h represents the orange fish gene. So we've got 3 generations here. Now what a question might ask you to do is determine what is the genotype of as many people in this genetic tree as possible. So why don't we go ahead and do that? So each level here represents another generation. So here's one, this would be the grandparents up here, and then this is one child, this is another child, this is another child of these 2 parents, and then these children had children of their own. So there's 2 children here and 2 children down here. All right, so if we look at each person here, and we'll label them. A, B.
We label them too.
I would. So person A, what is that person? That's a fish. Sorry, we're talking about fish.
It's a boy dominant.
It's a boy with a dominant gene. He's a purple fish. Now, do we know what his genotype is?
No. Dominant. 8.
We'll do a little investigating and see if we can figure it out. What about fish B?
The
Girl, purple fish, a girl with the dominant gene. Now, if you look at the offspring of those 2 fish, that would be C, that would be E, and that would be H. So these 2 fish, A and B, had 3 children. So you've got C, which is a girl, but what else? Recessive. We know that it is this fish C here is homozygous recessive. Had to get 2 of the recessive gene, right? We know that mom and dad fish, well, they must each have the dominant gene because they're both purple fish. But what else must they have? They also, each of them must have the recessive gene because one of these recessive genes in C came from father and one of the recessive genes came from the mother. So therefore, both of the parents must be heterozygous. You see how we were able to determine that?
Yeah.
All right, now we go on to fish E here. Fish E Well, we know that it's a purple fish, so the fish is going to have a dominant gene. At this point, can we say whether this fish E is homozygous dominant or heterozygous? Can't say for sure yet. Maybe later on we'll be able to figure it out. Maybe not. And then we look at fish H. Now, fish H definitely has a dominant gene, correct? Can we say with any certainty whether it's homozygous dominant or heterozygous yet? No, we can't. So let's look at the other ones that we can for sure say. Well, right away, which ones can we say without even thinking about it?
The white ones.
All the white ones, they're all homozygous recessive because they are not purple fish. They do not have the dominant gene. So F, G, and J are all homozygous recessive. Now, if we look at this pairing right here of C and D, well, D definitely has one of the dominant genes because it's a purple fish. But if you look at the offspring of C and D, J got two recessive genes. Got one from mom, therefore the other one had to come from dad. So dad has a recessive gene. Dad also has a dominant gene. So dad therefore must be heterozygous. Because the dominant gene means that he is purple, and he was able to give the recessive gene here to the child, J. All right, I, can we say with any certainty anything about I? We know that I's got a dominant gene. Is it going to have a recessive gene as well? Yeah, because mom only has recessive genes to give. So I is going to be heterozygous as well. What about K and L? What can we say about those two? They both have the dominant gene for sure because they're shaded in. So they both are purple fish. Well, what about mom?
Oh, yeah.
Mom only has the recessive gene. So therefore, K and L are both heterozygous as well. So even though we don't know the whole story about the father here, because H, we don't know if H is homozygous dominant or heterozygous, we can say with certainty what the children are. The children are both heterozygous because of the mother. So for a question like this, you may have to go through the family history, and it says, what information can you determine about each person? You notice I've got two sets of grandparents way up here, so it's quite an extensive family tree. Here we're looking at the genetic trait of having hairy knuckles. And hairy knuckles are dominant over non-hairy knuckles. So again, the shaded ones represent people that have hairy knuckles. Are you okay? So there's 17 people in this family tree, so you need to determine everything you can about them. On the video. So here are the answers. Person number 11 and person number 13 are the only two that you're unable to determine the genetic genotype for. We know they have the dominant gene, but we don't know if they're homozygous dominant or heterozygous. This concludes today's lesson.